Okay, we have go over these 4 problems. The exercise about the uniformly accelerated motion. It is basically governed by these 2 formulas. One for the distance, which is a function of time, with initial velocity and acceleration and initial position. So half acceleration t squared vt and initial start. Now the equation, simply apply this speed is at time plus initial velocity. So these 2. So the first question, let me read through. In one-dimensional motion with initial position, initial velocity, and constant acceleration can be expressed in this function. Once again, these 2. At t equals 0, an object at position 2 meters has the initial velocity of 3 meters per second. If the acceleration is 1 meter per second squared, what is the position at 2 seconds? So, and this is simply directly plug in to the time, and then you have 2 equal 1 acceleration 2 squared plus initial velocity, which is 3, and plus 2, and then that's 10 meters. That's easy. Important is you can find the equation. But if I applied another question attached to this one, what is the speed after 2 seconds? Then you simply apply this second equation, and then the speed is simply equal to 2 times 1 and plus 3, and that is equal to 5 meters per second. Now the second question. A moving object with uniform acceleration has the velocity of 12 meters per second in the positive direction, and when its coordinates is at 3.0 centimeters. It is in 2 seconds later, it is at negative 5 meters per second. And what is the acceleration? So just normally you're good to draw a little picture, and then you have starting position and go to the positive direction, and then later on to the negative 5. To the negative 5. Yeah, later on to the negative 5, and then so that way it was starting from here, and then goes to negative, therefore, and over here, and then you know the acceleration is negative. So therefore, you set up a equation of motion for this one, and then to find out what is the acceleration. Oh, actually number 2 continues. It's starting going to the right, and then go to the negative 5. So then we use the same equation, but this time we're not simply directly plugging in t. We don't know the acceleration, but we know something else. Therefore, but we still apply this equation so that position at 2 seconds is negative 5, and then equals to half a 2 seconds squared plus initial velocity times 2 plus 3. So everything is known except the acceleration. Simply we solve the equation and manipulation of the equation, and then find out a equal negative 16 meters per second squared, which makes sense. If you go into the right and then end up in the left, and then of course the acceleration got to be negative. Okay, last question, number 3. Same idea, same equation, but different initial and final conditions. A truck covers 40 meters in 8 seconds while uniformly slowing down to a final velocity of 2.8 seconds. Find the truck's original velocity, I will call it initial velocity, and find its acceleration. Normally, once again, it's good to draw a little picture, jot down some notes on the side while you read the question, so that will be helpful to solve the problem. So the truck is here with the initial velocity, and it goes 40 meters this way, and then smaller velocity 2.5. just from here, you know, final velocity is smaller, initial velocity is bigger, and then you know the acceleration is in a negative direction if we assume to the right to be our positive direction. Now we just write down our equation of motion. We have two. One for the distance, and so on the right hand side, which is actually our x of t, which is t is 8.5, and that is 40. Okay, so on right hand side, on left hand side, half 8, that's t squared, t is 8.5. And then the initial velocity, which I denote as vi, stand for initial, or here they are asking original, and times t. And the position, well, just 0. So x0, x0 is 0. So that's 0. So then that's the equation about the distance. But in this equation, there are two things that's unknown. What is the initial velocity? What is the acceleration? Only thing, but we cannot find out what it is. And then we have used some other information give us, and then we use the equation for the velocity. When the velocity is a function of time, therefore this is the final velocity, tv at 8.5. Okay, second later, it's 2.8. We know, so that is equal to the acceleration times t. So that's t and plus initial velocity, vi. We again don't know. But now we have two equations. One for the distance, the other for the speed, velocity, and two unknowns, which is the acceleration and the initial velocity. So this is like a linear simultaneous equation. It's like xy and yx. We had a quick review in the class, and looks like you remember it pretty well. So this is our review, and so for those of you who missed the class, still have a problem, and then you can review it. And then here is my solutions, because instead of using the video time, and then this is two simultaneous equations for two unknowns, the acceleration and the original speed. And by solving this, I use the substitution method. Students know there are substitution method, elimination method for this simultaneous equation. And I go through all these, double check my calculation, but finally I boil it down to the two answers. The initial velocity 6.1 meter per second, and the acceleration, which is definitely negative, and 4.40 meter per second. So you find the answers. So I sort of think this is correct because the acceleration is indeed negative. But whether it's exactly right or not, you can check with online equation solver. Okay, don't simply use the equation solver, but if you don't understand what the equation means. It turns out that it looks like most of you understand, still remember how to solve simultaneous equation, but it's a bit tedious. So now I will show you how to use the online equation solver to, in fact, all you have to do is click this link, and that will bring you to an equation solver. Okay, if you search for equation solver, menu will pop up, and one of the solvers I use more frequently is this equation solver from Wolfram, which can solve simultaneous equation. And what you do, you just key in the equations. Now, what equation we have? What I've done here, so we have 40 equals half, which I just put 0.5, times a, that's my acceleration, times 8.5, and then squared, so that's squared, and then plus a initial velocity, that's I just use a v, and 8.5, where there's no, that's the equation with two unknowns I cannot directly solve. But if I add another equation, so which is 2.8 down here, 2.8 down on the right. So yeah, my equation is still here. I just key in the equation. I already did it by hand, but I just use this to double check. So, and then in your homework, you can use any equation solvers. 8.5. So two equations and two unknowns. So V. So so that is two equations, one for distance, one for velocity, and two unknowns, one for x, initial velocity, and another for the acceleration. So then, if you double check, you type in this equation right, see if the equation is right. So if you look, that's the equation I want to type in, but then this is the equation I'm putting in here, and then so solve. So you go down here and see it go through. Yes, oh look, it has the solution. Find out exactly what I have as what I did. Okay, I'm not suggesting you do everything with equation solver if you don't know what you're doing. So then I had this solution. So then here you go. Then I have the solution. So that's the equation solver. It matches with my numbers. Hold on. Let me go back. Equation solver, solve the same question. You copy. I will put this a link so that you can use the one I use. So I click here and put it a link. So this is the trick for PowerPoint. You make this a link. So next time when you click here, you will get to equation solver, of course. Here, click. So that's where I use very often. It doesn't mean this is the best, but of course you should review your math 101 about simultaneous equations if you really forgot everything. What do you mean by a solution, and what do you mean by simultaneous equation, and variables, unknowns, and so on. So okay, our next topic will be vectors, but we are done with the linear acceleration questions and problem exercises. All right, hope this is helpful. Bye bye for now.